today's session is about centralized work management using Splunk tool. So some of you may already heard about this tool because we are in the middle of implementing it into the project Synco in this sprint, latest sprint. Actually, not in the middle, we are almost done with it. So the pending is to go live. Let's just discuss about what Splunk is and what is the purpose of using Splunk in place of the Synco project, Synco post system. So before moving to the Splunk, let's just get to know what is log centralization is. Now, as you know, when we are using a system, let's say like a Java system or a Java project or a PHP or a .NET project, we are using a login mechanism or a login framework to capture all the events, all the activities, and then all the file execution, method execution, likewise into a log file. So it could be like for a Java project, it could be like log4j, slf4j, or also then logback. And for a PHP project, it could be like log4php, and then for a Java project, it could be like log4net. So by using all these frameworks, we can track all the events, all the activities that happens in that project. So when it comes to a very large distributed project like ours or like Cisco, there may be tens of thousands of log files in that system. So those file size may be like 100 GB or more per day. So to handle those log files, to monitor those log files could be like very pretty much impossible, pretty much difficult. So in that case, we would be required a central location, a common location to handle all those logs in the system. So in that case, we will be introducing Splunk tool. Therefore, now Splunk is a common log management tool. Indeed. So then let's just look at the overview of Splunk. Now Splunk has mainly three parts, three sectors. One is the Splunk main server, indexing server, and then the other one is the forwarder, and the third one is the search head, or else we can say like web front end, web UI. And what Splunk indexing server does is it will capture all the events, all the raw data comes from forwarder, and then it will store those data in the Splunk storage, and they are using their own mechanism to store those data. So other than that, the next part is the Hadoop plugin and that Splunk server. So we can send all those data into a Hadoop system as well. And then we have in here, like I said here, we have Splunk forwarders, and then this is the Splunk server, and this represents the Splunk web UI. So we can use any project as Splunk forwarders. So what we have to do is add those forwarders into the system, and then do some settings, add some settings there. So we can use any mobile system, mobile application, or else any server applications, or else any post applications like ours. So we can establish a connection between forwarder to Splunk server using that forward lightweight application that is provided by Splunk itself. So then this third part is Splunk UI web portal. So that will the purpose of using that is to provide a UI front end for those index data, and also provide a search head for those data, searching application, and also that will provide monitoring, alerting, and also like analysis, reporting tool as well. as I said, these are the Splunk components. Mainly the forwarder is there. That's a lightweight tool that was provided by Splunk itself. So, the purpose of using forwarder is to forward all the raw data, machine data into the Splunk system, Splunk index server, and then indexer in the sense that is a indexing server which use their own mechanism to store the raw data, machine data comes from forwarder, and then again it will respond to the search requests that are coming from search head. The search head is the main front end, commonly the access point for Splunk web, Splunk server, and that will do the searching and all these other features. And Splunk, these are the data sources that can apply for Splunk. We can mainly add log files, directly add log files from through Splunk forwarder to the system, and then again we can add directories. So what will happen if we add directories is all the files inside the directory will be indexed in the server. If we add that directly to the forwarding path, and then again we have a network port. So if there's a situation like we are unable to add a forwarder, then we can directly use the DC to UDP port, and we can send those forwarding explicit connection to the Splunk server using that TCP UDP port. Let's say like adding Log4j adapter. Likewise, using those kind of mechanisms, we can send data to the Splunk server. And then again also we have scripted inputs. Splunk can read the machine data output by program source script such as Unix commands or a custom script. If you consider about how indexing happens in the index server, when raw data comes from forwarder to the indexing server, it will come firstly to the indexing pipeline, and in that indexing pipeline, it will divide those data into events, and then identify some common field, default fields such as source type and host name and time. Likewise, those will be identified in the first pipeline, and then those will be indexed into the particular indexing database. So we have now here three indexing databases, and then again the search head, the web front end, it will merge all those data and send it to the front end when a search request comes to that search to that search head. And this is the infrastructure of Splunk. Now we can see we can add a number of forwarders depending on the capacity of indexing server. So there we have added 3 indexing servers, and we can have multiple forwarders depending on that, and also we can have multiple search heads depending on the search request, search load. So that is the setup, but actually we don't use that much of a huge setup for Leapset Splunk. We are only using one indexing server, and there are multiple forwarders inside those host devices. And then again, let's just look what are the features that provided by Splunk. So the main feature is searching. Splunk server has most advanced searching mechanism, and they're using their own query language called Splunk Search Processing Language (SPL). So then once data is indexed in the Splunk indexing server, can begin searching it and manipulating those data using this Splunk query language. And also search commands enable you to use keywords, phrases, fields, Boolean expressions, and comparison expressions to grab all those data from the server. Then again, Splunk can be used as a analytical tool. So it aids in capacity planning by helping you to determine your hardware requirements and for virtual environments and forecast energy consumption as well. And then it enables enhanced root cause analysis that can help detect abnormal behaviors in the system. Also, it can prevent all security attacks. And other than that, it enables enhanced monitoring of key components, like which can detect system failures and prevent outages before they occur. And finally, we can use this Splunk tool as a tool to detect all the features, usage of the features. So let's say like in our POS system, we have a gift card. So by detecting an event or a logger throws when triggers when that gift card is used, we can identify how many merchants that are using this feature and how many are not. So likewise, we can use Splunk as a predictive analytical tool. And then again, the reporting. Splunk has reporting as well. So they have custom reports, scheduled reports, two types of reporting. And let's say now, if we run a query, a SPL query in a Splunk web, let's say a heavy query, and by using that results of that heavy query, we can create reports. So we can save those reports in this under this reports module, and we can use it in the future. Likewise, and then we can have scheduled reports as well. So then what scheduled report is, the report runs on a scheduled interval, and which can be configured to trigger an alert. Alerts in the sense like it should be an email. So likewise, we have reporting there. And then we found a very useful Splunk video demonstration. Let's have a look.
DevOps is all about improving communication and collaboration between developers, QA, and operations to help companies build, test, and ship new software faster and more efficiently. However, teams can struggle with the lack of visibility into different tools and systems, accelerated time-to-market pressure, and increasing complexity throughout the lifecycle process. Insight gathering can be manual and ad hoc, turning the time it takes to resolve issues into days or weeks. Without a single place to access and visualize data, or a simple way to correlate data from various sources, you don't have everything you need to deliver software to customers quickly and efficiently. With Splunk software, you can find, trace, and fix issues in real time at any point in the application lifecycle. Bugs that otherwise might take days or weeks to find can be tracked down in minutes. With the Splunk platform, you can collect, index, and correlate data from various sources. Once your data is in Splunk, you can quickly and easily search, explore, and visualize the data. Splunk can provide insight into data in any environment, like testing, staging, and production. And developers can search and visualize data from production environments without needing to access production machines. You don't have to know what questions to ask your data ahead of time. Splunk software is flexible about the data you put in. Splunk can handle everything from clickstream data, to syslog, to web access logs, to custom application logs, to back-end databases, and SOA architectures. By logging all the important information about your applications and users, you can achieve powerful analytics without the hassle of building special-purpose software. Splunk is also a powerful complement to the applications, tools, and systems that you use every day to build, test, and ship products. Splunk delivers application lifecycle intelligence, which enables you to track every code check-in, build, test pass, and deployment in real time. Splunk software can help you run DevOps practices like continuous integration and continuous deployment. Splunk empowers you to quickly trace and identify errors anywhere in the code base with real-time search and monitoring, delivers application intelligence from your logs, and provides real-time insights from the systems and processes that drive your application lifecycle. Download Splunk now. It's easy to get started. Visit us at splunk.com.
So rest of thing will be explained by Eshan.
Hope now you guys have basic understanding about the Splunk and what is Splunk capable of doing. So in the coming slides, what I'm going to explain is how we are going to use Splunk to establish the centralized log management part in our post devices. So these are the main components that we are using to do the centralized log management part. So basically we are using Splunk folder inside the post device. We are going to install it inside the post device, and also we are using Splunk indexing server and as well as Splunk web UI. So basically we are configuring the Splunk folder such that we can monitor the relevant log files. So our actual deployment environment looks like this. So basically we are maintaining two servers, one Splunk indexing server which is called mlog.leapset.com for maintaining production related log data, and the other one sandbox version for maintaining every other environment data. So basically once you install the Splunk folder successfully inside the post device, so it should be able to identify what is the merchant it has onboarded, and it should forward the data to the relevant indexing server. So, and also you can see that in the sandbox version we are maintaining several indexing databases. So basically what in the Splunk context, while the indexing database is the folder or location which Splunk keeps the data. So the idea of maintaining these sort of environmental specific data separate is so we can optimize our query without worrying for the other. Let's say if you want to search the data for a EST2 environment, so you can simply omit the other one and just execute your query on EST2 index. And as well as, but another advantage of this sort of thing is you can easily remove preferred index without affection to other indexes. So with this separation, we can easily manage our file storage as well. Then these are the folder configurations that we are using. So basically, if you consider Splunk, what it does is monitoring a log folder or log file, and when it receives some file, it will forward data to the indexing server. So there may be some network, maybe use some network bandwidth. So if let's say at the end of the day, post merchants cannot be affected from that bandwidth usage. So in order to avoid that, what we have done is that there are some configurations to control the bandwidth. So by using we have done some evaluations, and we have find a proper bandwidth rate, and we have configured it for the Splunk folder so that normal post devices won't get affected from that bandwidth usage. And also another thing is, like, when you consider the Splunk indexing servers, the most affecting part is not the processing power, it's all about data. So basically, if you have 10,000 of post devices, all of them are forwarding the data in your indexing server. So if you haven't enabled those compressions in the indexing servers as well as forwarders, you will running out of your space. So that configuration also we have done for the Splunk. And also if you consider Splunk, it's a third-party tool. So when we want to install some software or some package to post device, we are stick with that OS upgrade project. So it's basically what it does is, like, it can it can package our scripts or our installations into a Debian structure, and it will deploy those Debian files to the Leapset managed repository. So once you successfully do a OS upgrade or a Moxie upgrade, then those packages will be get installed in the post devices. That's how we manage to install. We manage to send the Splunk forwarder to each and every post devices. And another thing to mention is that if we wanted to find a way to configure that. Let's say we have to find a way that merchant specific data, like if we find an error block in Splunk web device, web portal, we have to identify which merchant, which post device, which error message is this. So basically, if you consider the web post device, it has a sort of a configuration file. So what we have done is feeding those configuration files. For the OS subject project. So basically, in the Debian, if you are familiar with the Debian packages, so we can provide installation scripts for the Debian packages. So what we have done is, during the installation, we have run post installation script and read that configuration file from the post device and add the relevant monitors and the log file based on the customer merchant device. So as you can see, we have added merchant ID and station ID, so we can clearly identify the relevant log file. And also there's another drawback or in the Splunk folder, it can't identify log quotation. So normally when the size exceeds, log file will get rotated, and Splunk still tries to send all log data to the Splunk server. So we have to avoid that as well. So we have used the whitelist operation, and it will emit everything. You can get only the .log extension. Let's say once the file get rotated, it will make error.log1 line. So those files will be needed. So once we have successfully packaged our Splunk folder, or after the OS upgrade, it will get installed with all these configurations. So after what we have to do is, for the moment, we are selecting some critical for the production environment. We are selecting some particular customers, those who are frequently raising some issues. So we are remotely log into those post devices and start Splunk server. So that's the reason is for now we are using a Splunk version with limited indexing capacity. So that's why we are limiting this forwarder to only the specific number of customers. These are the features, these are the basic steps that you can follow once you set up Splunk forwarder on a web post device. So basically in the Splunk UI, you can easily locate a specific data for specific merchant, and you can further go to the go and select a specific registry, and also you can select the file or a file which you are interested, and then you can execute your query on this selected data. So by using these steps, you don't need to, your search query will not be executed in all of the merchants. So as for the now, we are suggesting these steps when you want to get some errors, or when you want to get some warnings. And also, once you have a qualified query, based on those queries, Splunk can generates reports and charts, as Gihan mentioned. So next I will do small demo sort of thing, how we can use Splunk. This is a Splunk UI, web UI. So basically here, if you don't know anything about, let's say, Splunk, you can type whatever you want and just you can get the result. But what we are suggesting is, by using Splunk, you can select what are the post devices which you are configured. So these are the post devices which we have integrated, and as you can see, the first part is merchant ID, and the second one is registry, each registry. And also you can see the sources and source types, etc. Let's say if you, for an example, let's say we select that error log file. What does this mean is, so you have these sort of errors in your host devices. So if you want to select what are the host devices you have these sort of errors, you can simply just click this host part and you can see that this breakdown. And these sort of things can be done using Splunk. And also there are some, if you want to if you want to track a specific error, let's say you have an error called let's say if you want to find it, we have identified there is an error called printer configuration error. So you want to find out what are the host devices that has this error. So simply you can do this search. You can find. Will break down your result as per the host count, and you will see that these are the statistics that we have generated based on Splunk, and there are some visualizations as well. So you can select whatever the format you want, etc. And the advantage is if we can implement our event logs properly. For an example, let's say if we have implement event log for order flow, we can use this graph to determine what are the orders placed by the host during any time interval. So this time interval breakdown is also there. Like we can select today's results, and you can enter anything, like you can give a date range as well. So these are the basic functionalities that we can use Splunk and Splunk Alternatives. So if we consider Elasticsearch, Logstash and Gihan, this is the open source tool, 100% open source. This is equivalent to the Splunk. So if you consider Logstash, it is equal to Splunk folder, and Elasticsearch is Splunk head, search head, and the Gihan is the Splunk UI. So the reason, as Eshan mentioned, if you are going to use Logstash, there is a mechanism in Logstash that we can filter the data inside the file. So let's say in the log file we have errors, warnings, and we can configure Logstash to get the errors only. Those filtering mechanisms are there. But the reason that we cannot use this is Logstash is running using JVM, and it will grab the memory like 100 MB, right? But the thing is, when the Logstash is going to idle state, still it is taking the memory and it's not releasing the memory. But when it comes to the Splunk folder, what it does is, when it doesn't have to do anything, it will release the memory and give others to use that memory. That's the reason we can't use this open source framework. So there are some other frameworks as RTSLog. It also has some problems with duplicating errors, like log E and settle.